Chapter 5 Warm-Up, our Algebra 1 Exponent Review. The essential question, how do you use properties of exponents? There are several different properties of exponents. We're going to review each one individually, so let's go ahead and take a look. There were 6 problems left on the page. Let's go ahead and take a closer look at those. My first problem, the entire parenthesis is raised to an exponent, so everybody in this parenthesis is going to get that exponent. So the 4 gets the exponent, the q to the negative 2 gets the exponent, and the r to the negative 6 gets the exponent. This 4 already has just a single exponent, so we're going to leave him alone at the moment. Q has 2 exponents. Negative 2 times negative 4 is a positive 8. R also has 2 exponents. Negative 6 times negative 4 is a positive 24. Only negative exponents have to move to the other side of the fraction. So my answer is, here's my fraction bar. Q isn't moving, so here's Q. R is not moving, so here's my R. 4 to the 4th power had to move, and when he moves, he has a positive exponent, making sure my variables are in alphabetical order. P, Q, R, S. Yes, he's in alphabetical order, so I'm done. This entire parenthesis is raised to the negative exponent, which meant that 3 gets the exponent, that V gets the exponent, and the W gets the exponent. The 3 already has a single exponent, so we're going to leave him alone for the moment. The V, negative 2 groups of negative 4 meant positive 8. My W, you had negative 3 groups of negative 4, which means you had positive 12. Only negative exponents need to move. So my V and my W are fine. So V, W, my 3 needs to move. When it moves, it needs a positive power, making sure your variables are in alphabetical order. U, V, W, X, Y, Z, it is in alphabetical order, so I'm done. Even though your exponents are fractions, you follow the same principles. Everybody on the inside of the parenthesis gets this exponent. So my 5 to the 1/2 gets the exponent negative 1/4, and this 5 to the negative 3/2 gets the exponent negative 1/4. So 5, you have 1/2 times a negative 1/4. I now have a negative 1/8. This 5, negative times a negative is a positive. 3/2 times 1/4 is 3/8. Now that they all have single exponents, my base 5, this had 1/8 of them, and I need to add it to the 3/8 of them. So 5 to the 1/8 plus 3/8 is 2/8, which simplifies down to 1/4. And because the fraction is in the exponent, we need to make sure we know how to rewrite it with the radical sign. So here's my radical symbol. The base goes on the inside. The denominator is the root. The numerator is what you are raising everybody to in the end. Can I take the 4th root of 5? No, I cannot take the 4th root of 5. So these 2 are my final answers, and I'm done. Let's look at this next one over here. Everybody in here is raised to the negative 1 power. So that 3 to the negative 2/3 has the negative 1, and this 3 to the 1/3 has the negative 1. So I have 3 to the negative 2/3 times negative 1 is a positive 2/3. 1/3 times negative 1 is a negative 1/3. Now that they each have their own individual exponent, they're both base 3s. So I had 2/3 being added to a negative 1/3, which says my base 3 ended up having only a 1/3. Because my exponent is a fraction, you need to know how to rewrite it as a radical. The base goes on the inside. The denominator is the root. The numerator is what you are raising everybody to in the end. What is the 3rd root of 3? There is no number that I can multiply together 3 times and get the answer 3. So this is my final answer, and I'm done. Next one. Everybody on the inside gets the negative 1/5 power. 4 to the 5th gets the negative 1/5 power, and that 3 to the 5th gets the negative 1/5 power. 5 times negative 1/5 is a negative 1. My base 3 5 times a negative 1/5 is a negative 1. They each have their own exponent now. They just happen to both be negatives, which means they are on the wrong side. So here's my fraction bar. 4 needs to go down to the denominator. 3 also needs to go down to the denominator. There is no more numerator, so it's Secret Ninja 1. So this is 1 all over 12. Last one. Everybody in here has the second power. So that 6 to the 1/2 has the second power, and that 4 to the 1/3 has the second power. 1/2 times 2 is 1. 1/3 times 2 is 2/3. 6 to the first power is 6. This has its own exponent, but we need to make sure that it cannot take the radical of it. So here's my radical. Base goes on the inside. Denominator is the root. The numerator is what you're going to take this answer to in the very end. Can you take the third root of 4? No. Which means both of these are your final answer, and you are done.